In lesson 74, we're looking at uniform motion with both distances given. This is very similar to the problems that they had set up for us where there were 4 different variables and then 4 equations where we had to do some double substitution basically. So we have to set those up on our own now. In the first example, we have Friar Tuck, who rode the 24 miles to the fair in Nottingham at a leisurely pace. He stayed too long at the fair and had to double his speed on the way back in order to get home in time. If his total traveling time was 9 hours, how fast did he travel in each direction, and what were the times? Okay, so we're finding all 4 variables, both of the rates and both of the times. So, we have his rate to the fair, and that would be multiplied times his time to the fair. That equals 24 miles. Okay, and then we have his rate from the fair times his time from the fair, which would also be 24 miles because he's just headed back. Alright, and then in the next one we have a comparison. It says his rate back, let's see, he had to double his speed on the way back, so for his way back equals 2 times his rate going to, and I used T for to and F for from, to and from. And then the last one for our comparison of times, it says his total traveling time was 9 hours. So I would have his time to plus his time from equals 9. Okay, so that's our 4 equations that they had been giving us, and now we have to set up on our own. Now I have the R sub f solved for, so I'm going to be subbing into this equation here. So that means I need to get the t sub f by itself. So I would subtract the t sub t. So t sub f equals 9 minus t sub t. And now I can substitute this in also. So I know R sub f is 2 times RT. So I put that in place of the R sub f. And then T sub f is 9 minus T sub t. And then those are equal to 24. Then I'll distribute that 2 R sub t across. So I'll have 18 R sub t minus 2 R sub t, T sub t, and it's still equal to 24. Now R sub t and T sub t, we see here that equals 24, so I can replace that with the 24. Alright, let me move down the second example just to give us a little bit more room here. Alright, then I would multiply my negative 2 times 24, so it's negative 48. And then I would add the 48 to move it to the other side. So let's see, I have 8, 9, 10, 11, 12, and then 6, 7, so that's 72, and then divide both sides by 18. So R sub t equals 4. Now I can use this information to find my other 3 variables. So if I put that into this equation, I'd have 4 T sub t equals 24, then I would divide both sides by 4. So T sub t equals 6. And then I can put that in here to find what r sub f is. So 2 times 4, r sub f equals 8. Then I can go ahead and put the 6 in here, so 9 minus 6. So t sub f equals 3. Alright, and then just to make sure that we have our right units, it was in miles and hours. So that's 4 miles per hour and 8 miles per hour. And then his time is in hours. Okay, so this was his rate to the fair, and then his rate from the fair, and his time to the fair, and his time from the fair. Alright, the next example we set up very similarly. We're going to set up those 4 different equations to find the 4 variables. So example 2 is Atlanta ran 4 times as fast as her challenger. In fact, she ran 80 miles in 2 hours less than it took her challenger to run 28 miles. How fast did each of them run, and how long did they run? That seems wrong. I think, did they run? Okay, so rate, time, and distance. So we have the rate of Atlanta and the time of Atlanta is going to be 80 miles. We have the rate of her challenger and the time of her challenger, and that would be rate times time is distance, so it's 28 miles. Okay. And then they give us some comparisons here. It says Atlanta ran 4 times as fast as her challenger. So Atlanta's rate would be 4 times the rate of the challenger. And then it gives us a comparison of the time. So Atlanta's time, let's see, it says she ran 80 miles in 2 hours less than it took her challenger to run 28 miles. So the challenger's time minus 2, because it was 2 hours less. And now I'm ready to start subbing things in, because I have the RA by itself and the TA by itself, so I could substitute those in for this first equation. So I have 4R6C times T sub C minus 2, so that's just filling in for the RA and the TA, and then that's equal to 80. Then distribute the 4RC across, so 4R sub C, T sub C minus 8, R sub C equals 80. And the R sub C, T sub C is equal to 28, so we can fill that in. 4 times 28 minus 8 R sub C equals 80. Let's see, now 4 times 28, that's 112 minus 8 RC equals 80. Then I would subtract 112. So negative 8 R sub C equals negative 32. Then divide both sides by negative 8. So R sub C equals a positive 4. And now we're ready to use that information to find our other 3 variables. So for r sub c, I can put that in here to find out what r sub a is. 4 times 4, that would be 16. Okay, and then I can fill in this r sub c here to find out what t sub c is. So 4, there we go, 4 t sub c equals 28. Divide both sides by 4, so t sub c is 7. Alright, and then I still need to find out what my t sub a is, so you would fill that in here. So t sub a equals 7 minus 2, so t sub a equals 5. There we go. So now I have Atlanta's rate, and let's see, this was in miles and hours, so it's going to be miles per hour for the rate. And then the times will be in hours. And now we've got all 4 variables.